Proper integrals?
Yes, ma'am.
Exercise number 9 completed? Or remaining?
त्यो याच र याच प्राइमको चाहिँ म क्वेशन अनुसारै देखाउँछु भन्नुभएको थियो, त्यही चाहिँ बाँकी छ होला।
ओके, इम्प्रोपर इंटीग्रल पनि सुरु भइसक्यो।
भइसक्यो म्याम।
ए म त तिमीको कोर्स धेरै पछाडी परे जस्तो मानेथे, त्यस्तो पछाडी त रहेनछ।
हजुरको त्यही एउटा क्लास छुटेको हाम्रो आजसम्म।
ए हुन्छ, आज कभर अप हुन्छ नि। Okay, so we have done question number 3. This one. यो चाहिँ हाम्रो भइसक्यो।
Yes, ma'am.
यो चाहिँ भइसक्यो, लास्ट दुईटा क्वेशन बाँकी छ। ओके, so look at these two questions. Observe these two functions. Last two, 4 and 5th one. Observe them and tell me what's going on here. What's going on here? Why are they improper integrals? Why are we calling them improper integrals? Yes.
बिचको एउटा पोइन्टमा चाहिँ इन्फाइनाइट छ फंक्सन.
What is that point for both of them?
1 र 0.
1 and 0.
Yes, exactly. So you got it right. So what do we see? That here in fourth one, your f of x tends to infinity as x tends to, for this it is 1. For the other one, f of x tends to infinity as x tends to 0. Okay, so with in between limits of upper limit and lower limit. So you remember graph? We have done graph. We have understood this part graphically. You have this graph. Your point for fourth one is, let's take the example of 4. 0. Sorry, 0 to eta bhaina ni. So 0. 0 is your starting point. तिमीको 1 मा चाहिँ प्रब्लम भयो अनि 2 मा चाहिँ upper limit भयो. 2 is their upper limit. So how are we going to break this function? You know how are we going to deal with this? You remember? We have done already.
Yes, ma'am.
0 to 1 and 1 to 2.
No. 1 मा त discontinuous. So how can we assume 1?
1 minus h.
Only one.
Yes, exactly.
1 plus h is 2.
We have to avoid 1. What are we going to do? We are going to start from 0. We are going to reach till 1 minus h. We will find out this much of area first. Then we will skip 1. Then we will start from 1 plus h dash till 2. So we have to take two different integrals. We have to break it into two different integrals. Similarly, second मा चाहिँ तिमीको limits of integration के हुने भयो? -1 to 0 minus h and then 0 plus h till 2. Same way, है ना? So let me show you. Next step. Okay, so look at your data चाहिँ अलि confusing हुन सक्छ. Let's shall we cover it one by one together or one by एउटा question ला पहिला complete गर्ने? दुईटालाई सँगसँगै हजुर
एउटा क्वेशन कम्प्लिट गरेर जाऊ न.
एउटा क्वेशन गरौँ है, किनकि यो चाहिँ अलि कम्प्लिकेटेड हुन सक्छ. All right, so your C point भनौँ कि discontinuity हुने point चाहिँ 1 भयो. So we have already decided that we will start from 0 till 1 minus h, then 1 plus h dash till 2. So that's what we have done. Zero till 1 minus h, 1 plus h dash till 2. Now let me ask one question. Time lag bhairasa. Whatever I'm trying to show, are you getting it that very moment, or there is a lot of time gap?
Time gap.
Iras. Okay, that's good. If you face such problem, do let me know. Yes. So this is done. Now next step. What is your next step? Next step ma abhai hamle integration गर्ने हो. How do you integrate dx over 1 minus x square? Can you tell me what is integration of dx over 1 minus x square?
1 by 1 minus x.
Very good. So your function after integration is 1 by 1 minus x. In both cases, integration the same hunu payo, and only your limits of integration is different. First case ma chai 0 to 1 minus h, and second case ma chai 1 plus h dash till 2 will be your limits of integration. Our limits of integration apply garnu paryo next step. So you need not to worry that you are missing out. You are you trying? Do you try to note it down? Whatever is shown in your screen, do you try to note it down that very moment?
Yes, ma'am.
Yes. तो तिमीको टाइम धेरै कन्ज्युम हुँदैन नोट गर्नमै टाइम जान्छ म चाहिँ यो लोड नै गर्छु अपलोड नै गर्छु यु नीड नट टु वरी अबाउट इट just understanding part is very important. Okay, just look at your screen, understand this. By the evening I will be uploading these things. Okay, my preparedness my upload garchu by evening. All right, I just need to take manage this solution part, and I will upload it by evening most probably. Okay, so छिटै नै अपलोड हुन्छ. सो नोट गर्नेको टेन्सन नलिऊ, जस्ट ट्राई टु अन्डरस्ट्यान्ड.
स्क्रिनशट भन्दा पनि फाइल नै पठाइदिए पनि हुन्छ म्याम.
फाइल पठाउँदाखेरि के प्रब्लम भयो भनेदेखि यो एकदम छोटो भएर आयो अनि त्यसलाई जुम गर्दाखेरि अनक्लियर भयो. त्यस्तो मैले फर्स्टमा त्यही नै ट्राई गरेको हो, बट इट डिडन्ट वर्क आउट. ओके, द्याट्स वाइ. मलाई त धेरै सजिलो हुन्थ्यो नि त्यसरी गर्दा त, म एक किसिमको काम हुन्थ्यो. तर मैले के गर्नु परेछ, आई निड टु म्यानेज इट. स्क्रिनमा कसरी सबै राम्रो ठुलो देखियोस् त्यसरी म्यानेज गरेर यताउता एक्सचेन्ज गरेर, एन्ड त्यसको आई एम युजिङ स्निप टुल कि के टुल हो यो? दिस इज yes, snipping tool. I'm using a snipping tool and taking out the cutouts and uploading. Okay.
Yes, ma'am.
Yes, next step. Let's decide next step. We have to apply limits of integration. Would you like to try? I will show you this step in the screen. Just give it a try. What is your solution? You will apply limits of integration, then put h equals to 0 and h dash equals to 0. See what do you get. Try it quickly.
Infinity output.
Yes, very good. Infinity. Okay, so upper limit, when you put 1 minus h, what are you going to get? 1 over h. I know. When you put 0, you will get what? Minus of 1. All right, first butter. Your expression sort out where. Now let's do this one. Plus, let's put 2. 2 put garera, we will get minus 1. And minus of, अब यो राखौं 1 plus h dash. So 1 over 1 plus h dash will give you minus plus 1 over h dash. So I haven't written limit h tends to 0 and h dash tends to 0. It's quite obvious. So what's happening? 1 over 0 is also infinity. 1 over h dash, 1 over 0 is again infinity. So infinity minus of some constant is again infinity. Infinity plus infinity. You open infinity by this one. You see, this is also going to give you infinity. This is also going to give you infinity. Infinity plus infinity is infinity. Infinity minus 2 is also infinity. So your final answer is infinity, or you can say integral does not exist. Does not exist, DNE. All right. So here your integral does not exist. Now let's look at another one. Same way. Yes.
एकचोटि
Yes.
मैले एउटा सोधेँ एन्सरमा चाहिँ यो अनि प्रिन्सिपल भ्यालु -2 यताउता भनेर दिएको छ त्यो चाहिँ कस्तो हो म्याम यसो बुझाइदिनु
Wait. Principal value को कुरा अब आउँदैछ. I have to explain that part. Okay? अब आउँदैछ from this question.
हस् ओके नि
You see, you know that you have discontinuity. Let me write it down. F of x tends to infinity as x tends to what value? Your case में 0 minus discontinuity. So what are we going to do? We are going to break it from -1 to 0. 0 plus, sorry, not plus, minus h, and 0 plus h dash till, what is it? 2. Upper limit is 2. So that's what we have done here. -1 to 0 minus h, 0 plus h dash to 2. Okay. So that's your next step. We are going to break your integral into two parts according to where it is discontinuous. This part is clear? I hope all of you are able to understand whatever I'm trying to say. कसैलाई केही problem भइरहेछ कुनै स्टेपमा problem छ भने please ask me that very moment. Don't let your doubts, don't pile up your doubts. Okay? Next step, we have to simply integrate this function now. How will integrate? What is the integration of dx over x cube? Very easy.
-1 by 2x square.
Very good. -1 by 2x square. So we got the result also. Now we have to simply put limits of integration. So can you tell me what will you get after applying limits of integration in this case?
Infinity, man.
Again infinity, or you can say no particular value does not exist. Integral does not exist. Indeterminate form भने नि भयो because एउटा केसमा चाहिँ प्लस इन्फिनिटी छ अर्को केसमा चाहिँ माइनस इन्फिनिटी छ and plus infinity minus infinity is indeterminate form, so no constant answer. All right, so upper limit, when you apply this upper limit you will get this expression. When you apply this lower limit you will get this expression. Your upper limit but -1 by 8. This lower limit gives you 1 by 2 h dash square. Now it's the time that we talk about principal value which you were asking for. I know. Let's observe. Okay. When you put h equals to 0, what are you going to get? You are going to get minus of infinity here. Minus of infinity here. And when you put h dash equals to 0 here, you will get plus of infinity. So you get 1 minus infinity, 1 plus infinity, which is indeterminate form. You don't have a constant answer for this. So your integral does not exist. No finite answer. So what is the conclusion? Let's change the scenario. Let's do one thing. Let us take, let me rub all this. What will happen when you take h equals to h dash? Last time maybe you asked or not, I don't remember, but normally students ask why can't we take h equals to h dash? H and h dash same. Okay, why we have to take two different limits? So let's see what happens when you take h equals to h dash. What happens? This is okay. Let it be same, but the second expression will also be, let's say, 2h square.
त्यो दुईटा चाहिँ क्यान्सल भयो तर इन्डेटरमिनेट फर्म हुन्छ नि त हामीले त्यो चाहिँ देखिदैन सुरुमै.
What are you saying? दुईटा
अब
क्यान्सल भयो.
हेर्दाखेरि चाहिँ पहिले क्यान्सल होला जस्तो देखिन्छ नि त. तर दुईटै के हुँदाखेरि चाहिँ इन्डेटरमिनेट फर्म आउँछ.
Yes, I know. So यो दुईटा cancel out भयो, यो दुईटा cancel out भएर तिमीको final solution के हुने भयो? What will be your final solution? Just solve these two terms. Let h equals to h dash. When you do this, your result for integration will be, what is it?
3/8.
3/8.
Yes, exactly, 3/8. Now, what is this 3/8? This is what is called principal value. Can I just write PV? Principal value, okay? Now let me ask you something. You have got 3/8 by putting h equals to h dash. Now let's start with the beginning. Look at this integral. What do you think 3/8? What is 3/8 for this integral? What is this principal value? Just make some observation. Think about it. के होला यो 3/8 भनेको? Before I tell you, I want answer from you. I want my class to be very, very interactive.
हामीले डाइरेक्ट इन्टिग्रेसन गर्दाखेरि यसो लिमिट नलाउँदाखेरि आउँछ क्या 3/8.
Very good, very good. Yes, exactly. That's the answer. Okay. So what is your principal value? You got it. Your principal value is the value which you will get when you forget the fact or you are unaware of the fact that this is your improper integral. Okay. अब तिमीले 11th 12th स्ट्यान्डर्ड मा हेर्दा फेरि के तिमीले यो इंटीग्रल में केही प्रब्लम देखिन्थ्यो होला? नो, हैन? तिमीले यसलाई नर्मल सिम्पल इंटीग्रल बुझ्थ्यौ अनि त्यसलाई सल्भ गर्न जान्थ्यौ. सल्भ गर्दा फेरि तिमीहरुको सल्युसन, in the other words, I can say that we can say that if you solve this integral following your 11th and 12th process, or you can say your knowledge of 11th and 12th standard, or your improper integral पढ्नु भन्दा अगाडि तिमीले यो इंटीग्रल सल्भ गरेको भए तिमीहरुको रिजल्ट के आउँथ्यो? Your result would be 3/8, which is not the fact, which is not true answer. So this is your principal value. So what is your principal value? The wrong solution, or you can say solution which you will get by ignoring the fact that your integral is improper integral. Okay, जब actually तिमीले के गर्नुपर्ने? You are going to split your integral into two parts. You are going to take limit h tends to 0, h dash tends to 0. You will solve it this way and you will get the non-finite solution. So that's your actual, or you can say correct answer. This 3/8 is not your correct answer. All right? Ab bujhe?
Yes, ma'am.
Okay. So now let's do one thing. That's all for improper integral. Improper integral ma chai yati matra garu. Yati नै भयो. Did I mention about your standard improper integrals?
म्याम त्यो त गर्नु भएको छैन. म्याम एउटा क्वेसन म सोध्छु नि हजुरलाई. यो म्याम इन्फिनिटी प्लस इन्फिनिटी भनेको इन्फिनिटी नै हैन त?
हो.
अनि माइनस हुँदा नि इन्फिनिटी त इन्फिनिटी नै हुन्छ है? कि कसो हो म्याम?
Infinity minus infinity is not infinity.
हुँदैन म्याम.
भन्नै मिलेन. के
इन्फिनिटी
पनि
प्लस
भन्न मिलेन. Very large value minus of very large value. त्यो त्यसको कुनै फिक्स भ्याल्यु नै भएन. Indeterminate के जस्ट यस्तो सिचुएसन भयो कि जस्ट
इन्फिनिटी चाहिँ
minus infinity you can say.
हो के हैन म्याम?
हजुर. In this case you can say it's minus infinity. Plus infinity भयो हैन? But very large value minus very large value, you did a subtract हुँदाखेरि I normally what students say infinity minus infinity is 0. It's not fact. तिमीको infinity भनेको 1 million पनि हुन सक्छ, 1 million 1 पनि हुन सक्छ, 1 million 2 पनि हुन सक्छ. Yes or no? 2 billion पनि हुन सक्छ, whatever, हैन? So very large value minus very large value can be some finite answer, कुनै finite answer हुन सक्छ तर त्यो के fixed finite answer छ, infinite पनि हुन सक्छ तर fixed finite answer पनि fixed छैन. So यस्तो सिचुएसन भयो कि जसमा हामीले हाम्रो सल्युसन को बारेमा के भन्नै सक्दैन. That is why we call it indeterminate form. It's not zero. You got it?
Yes, ma'am. Yes.
That's why this is indeterminate form.
Ma'am.
Ma'am, अनि यो इन्फिनिटी प्लस इन्फिनिटी पनि इन्डिटर्मिनेट फर्म चाहिँ हो कि हैन रे म्याम?
होइन.
यो चाहिँ योमा त हामी ठ्याक्कै भन्न सक्छौं नि त के रे
इन्फिनिटी नै हो.
यसलाई चाहिँ इन्फिनिटी नै भन्न सक्छौं नि त.
Infinity, very large value plus very large value is again a large value. Yes or no?
Yes, ma'am. Yes.
हैन? So infinity भन्न मिल्यो नि त. It's not indeterminate. It's different. Indeterminate and infinity is different concept. All right? त हामीले कहिले infinity लाई indeterminate form मा के हाम्रो infinity आएछ? It's infinity over infinity, 0 over 0, 1 to the power infinity. We have 7 indeterminate form, हैन? But infinity does not comes under indeterminate form. You have studied this when you were studying limits of integration, हैन?
अनि म्याम यो 1
So
को
not
पावर
limits of integration, limits. Yes.
1 को पावर इन्फिनिटी पनि इन्डिटर्मिनेट हो म्याम. हाम्रो 1 को पावर जति राख्दा नि 1 नै हुन्छ भन्थ्यो त.
भनिन्छ तर यो चाहिँ very very large value भयो. यसको पनि रिजन छ. यो तिमीको के छ भन्देखि यस्तो एक्सप्रेसन आउँछ something like this. के हुन्छ भन्देखि यो तिमीको एउटा एक्सप्रेसनबाट I actually अहिले चाहिँ मलाई याद आइरहेछ न तर तिमीको एउटा टर्मबाट यो सबै इन्डिटर्मिनेट फर्म बनेर आउँछ. If you want to know that, I will explain it next time. मैले अहिले चाहिँ ठ्याक्क बिर्सेँ तिमीहरुको के थियो 1 to the power 0 हो कि के गरेर आउँथ्यो. एउटै कन्सेप्टबाट सबै इन्डिटर्मिनेट फर्म बनेर आउँथ्यो.
इन्फिनिटी को पावर 0 भएको के हुन्छ म्याम?
Infinity to the power 0 is also indeterminate.
इन्फिनिटी एन्सर आयो भने त्यसलाई डज नट एक्जिस्ट लेख्न मिल्दैन नि म्याम?
मिल्छ. तिमीले अहिले सम्म इन्फिनिटी आन्सर आउँदाखेरि डज नट इंटीग्रल डज नट एक्जिस्ट नै भनेछ नि. Integral does not exist भन्नको meaning you are unable to get one finite area, finite answer for your integration. Okay, so if you get infinity also you will write integral does not exist. If you get indeterminate form like in this case, then also you will say your integral does not exist. Okay, when you are unable to get one finite answer, you will say your integral does not exist.
म्याम सुन्नु न, जस्तै यो यस्तै खालको क्वेशनमा चाहिँ एरियाको क्वेशन छैन तर जुन यो डिफाइनाइट इन्टिग्रलमा चाहिँ हाम्रो एन्सर इन्फिनिटी आछ भनेदेखि त्यसलाई डज नट एक्जिस्ट लेख्ने कि इन्फिनिटीमै छोड्नु?
इन्फिनिटी भनेर लास्टमा इन्टिग्रल डज नट एक्जिस्ट लेखे पनि हुन्छ.
त्यहाँ एरियाको कुरा छैन भने पनि त्यस्तो गर्ने.
एरिया इन्टिग्रल भन्न साथ एरिया भएन?
त्यो त भयो के रे, तर यतिकै डिफाइनाइट इन्टिग्रल मात्रै भनेको के सर हुँदैन?
अहिले यो हामीले गरेको डेफिनेट इन्टिग्रल नै त हो नि हैन? Isn't this definite integral?
यो त हो.
यो पनि त एक हिसाबले एरिया निकाले जस्तै त हो नि.
त्यो त त्यस्तै
एरिया निकाले जस्तो
दिनी
हैन,
भनेको
एरिया नै निकालेको.
एरिया अन्डर द कर्व नै हो दिनी त.
एरिया निकाले जस्तो हैन. के यो एरिया नै हैन?
हो, एरिया हो. त्यही कर्व
देन
एरिया हुन चाहिँ.
हो.
Okay, ma'am.
Shall we start new topic now? Bio queries complete bio. Let's start with new topic. Did I mention some standard improper integral in last class?
No, ma'am.
No? Okay, let me do it right now. There are few, you can go through your books and see there are some there are few standard.
म्याम हजुरको आवाज आएको छैन.
म्याम हजुरको भोइस आएन।
म्युट म्युट भएको छ कि क्या?
म्युट पनि देखाएको छ यहाँ, अनम्युटेड पनि भने छैन।
अरे केही बोल्नु नै भएको छैन कि? ए म्युटेडै छ।
बोलिरहेको छु।
ए सुन्दैन म्याम,
सुनिरहेको थिएँ।
अलि स्ट्यान्डर्ड बाट चाहिँ सुन्दैन।
आवाज आयो अहिले? अहिले आयो?
सुनियो म्याम अब।
Okay. So some standard improper integral. There are two integrals जसको solution तिमीहरूले अहिले हेरे नै बुझ्छ, दुई तीनटा integralहरू छ. So let me just quickly mention those. यस्तो छ, it's already solved for you, so I will not go through the solution part. You can look at it on your own, but there are rest of this improper integrals. यो दुईटा चाहिँ सल्युसन कम्प्लिटली बुझिन्छ, एकदम क्लियर छ हैन. बट जुन बाँकी इम्प्रोपर इन्टिग्रल्स छ त्यो तिमीको नयाँ तरिकाले नयाँ मेथड्सले गरेछ, which you haven't yet introduced to, which you will study later. हाम्रो कोर्समा छ, हामीले पछि पढ्ने हो. सो अहिले हेर्न पुग्यो भने you won't understand. So there is one is standard improper integral done with the help of differentiation under integral sign, which is also one of the topic. One improper integral is exactly your gamma function, which also we will study most probably next to next lecture or next lecture ma hame padchham haina. So you have to keep patience. जब हाम्रो त्यो टपिक्सहरु कभर अप हुन्छ, then you go through these standard improper integrals and you will be able to understand the solution part. अनि एउटा दुईटा त हाम्रो तिनी टपिक्सहरु कभर अप गर्दाखेरि नै आउँछ. There are 4 to 5 standard improper integrals. So you go through the solution of these two. Very easy. के गरेछ, simply definitely you will apply the concept of improper integral. You will introduce limits. B tends to infinity in both the cases. Your upper limit is infinity. And you have direct formula for these two. तिमीको यसको लागि direct formula छ. I hope you know that. Direct formula छैन भने पनि what you will do? You will integrate. How do you integrate this?
By parts, ma'am.
Yes, exactly. You will apply integration by parts. One of them is trigonometric, another one is exponential. So which one will be your first function? This will be your second function. Yes. Okay, so this will be your second function, and you solve it using integration by parts. You will get the result, and then you will apply limits of integration. So you can go through your solution part for both of them. All right?
Ma'am.
Yes.
त्यो कस वालामा मैम त्यो बुकमा चाहिँ इमेजिनरी नम्बरमा लगेर गरेछ हैन, त्यसलाई बाइपासबाट
मिल्छ. यसरी नै गर्दा सजिलो छ तिमीहरुलाई. जुन मैले भर्खर भने नि त्यसरी गर्दा हुन्छ. आफूले गर्न मिल्यो त हैन, तर तिमीहरुले त्यो मेथड हेर्यो भने पनि बुझिन्छ.